This is a test tile. This is a test tile. This is a test tile. And even this could be considered a test tile, depending on what you're testing. So, what are test tiles in ceramics, and why can they take so many different forms? The short answer is that there's no universally correct test tile, although I think ones with faces are significantly better than ones without. At the most simple level, test tiles are how we test clays and glazes on smaller, disposable pieces. Test tiles are an important part of the process of testing new glazes and or clay bodies. They tend to be made in bulk to a very simple design, with choices made for speed rather than quality, as they're typically a throwaway piece with no value after the test has been concluded. There are quite a few different ways they can be made, but generally they'll follow the process that you use for your main body of work. As in, if you slipcast your pieces, you'll probably slipcast your test tiles. The same is true for throwing or hand building. They can be as simple or as complex as you want, but there are a few basic concepts to think about when deciding how to make your test tiles. The main consideration for any test tile is the information you want to get out of that test. Typically speaking, this will be informed by the kind of work you make more broadly, and will generally benefit from test tiles that are as similar to that work as possible. There are also other practical considerations that will affect the way that you make your test tiles. The main considerations for information that you want to get out of a test tile are things like the clay body that you use, the surface and the edge quality of your work, and glaze thickness and application. The considerations based on practicality will be things like the end use of the test tile, the number required, and any information that you want to be able to add to the test tile. And I'll go through that full list in more detail now. The clay body that you use. Different clay bodies will have different thermal expansions, which is the characteristic that determines whether a glaze will craze or not. There's a popular misconception that opening the kiln early causes crazing. It doesn't, but it can accelerate it. Crazing is actually caused by a mismatch in the thermal expansion between the clay body and the glaze. These are fundamental characteristics based on the chemistry of the clay body and the glaze, and they don't change based on how quickly you open the kiln. Instead, what happens is as a material heats and cools, it expands and contracts slightly, and if your clay and your glaze do not have very similar thermal expansions, as they cool down and the glaze solidifies, the glaze will shrink more as it cools, only fractionally, but enough to cause cracks. It'll shrink more than the clay body does. This characteristic is unique to each clay and is different to the clay shrinkage number you will get from a manufacturer, although that is something else that we will discuss later. So it makes sense to test a glaze over every clay body that you intend to use it for if you want to find out whether or not it will craze. Glazes will also change their appearance based on the colour of the clay. So if you use multiple different colours of clay, it makes sense to test the glaze over each colour. Thankfully, this doesn't require a new test tile for every single colour. You can brush a slip made of one colour clay over a test tile made of another colour clay, and you will get the colour information from the slip that you have brushed on. If you have a light clay and a dark clay, I would recommend brushing the slip of the dark clay onto a tile made of the light clay, as you're less likely to get colour bleeding through from a lighter clay to a dark, but I don't think it's that important. The surface quality of your work. Glazes will behave differently on different surfaces, and it's best to match the surface quality of your finished work. So whether you smooth the surface of your pots with a rib or add surface texture as part of the making process, you'll learn more from your test tiles if they match the main body of work. Again, you don't have to limit yourself to just one on a single test tile. If you use both textures, you can do a test tile with both on them. The edge quality of your work. Glazes will break over the edge of a pot, so think rims, lips, handles, etc. differently depending on the glaze thickness and viscosity, as well as the way that the clay is formed. Sharp edges will give a completely different result to a rounded and burnished edge, and it's sometimes possible to add whichever quality you want to your test tile so that it will give you that information as it relates to your main body of work. Thickness or absorbency. To get an accurate idea of how a glaze will apply to a piece, particularly if you dip your pieces, the test towel should be a similar thickness to your actual pieces. Ideally, a 3-second dip of a test towel will apply a similar amount of glaze thickness as a 3-second dip of a full-size piece, as that gives you more useful and applicable results. From a practical point of view, this just means making sure the thickness of your test tile is not massively thicker or thinner than your actual pieces. Clay, shrinkage and vitrification. Unlike test tiles, which have the goal of testing a glaze, you can make tiles to test a clay body. These test tiles will take a different form to glaze test tiles, so the previously mentioned considerations don't apply, but they are an important part of assessing a new clay body. The design considerations for a clay test tile are quite straightforward. To test the shrinkage, all you need to do is have a piece, normally a slab, of a known length that you can compare the length that it started at to after it's been fired fully. And to test the vitrification, all you need is a fairly smooth lump or slab of clay that you fire to full temperature. You then weigh it as precisely and accurately as you possibly can and soak it. The industry standard is to boil it for 5 hours. If you can boil it for more like 2 hours, that will give you a good reading, or you can leave it in water for several days to see how much it absorbs, and then you take it out, remove any water from the surface and reweigh it. The difference between the pre-soaking and post-soaking numbers can be used to calculate the absorption. End use of the test tile. This can be unimportant or can have a significant impact on the test tile design. In settings like a shared studio, where glazes are a shared resource and tests will often be displayed publicly as examples, there are design elements that can make this easier to display. Tiles with a flat back can be stuck to a board, tiles with holes on can be hung from hooks, smaller tiles can be attached to glazed buckets, and so on. Tiles can be throwaway, they can be designed to be kept as ornaments, or designed to be used as practical objects. This also affects how they will be made. Number required. If you're doing an extensive round of glaze testing, like you would do if you take a ceramic materials workshop course, you might need hundreds of tiles. That means a small increase in the complexity of the tiles can scale up to hours more time spent making them. That might still be worthwhile to you, but it's worth taking that into account and maybe timing yourself on a small batch and multiplying to see if you really want to spend that much time on the full quantity. Whereas if you only need a handful of tiles, it's far less important to factor in how long they take. The final practical consideration that I thought of, although I'm sure I will have missed some, is the information that gets added to a test tile. Both through the firing and added afterwards, it's worth considering what information you want to be on the tile to help you remember the test when you come back to it later, because unlabeled test tiles are essentially useless after you've forgotten what the glaze was. For information that can survive a firing, the options are something like an underglazed pencil or a carved or stamped mark. For information added afterwards, a permanent pen is a good choice. For either of these, having a large flat surface will allow you to record more information on the tile easily. Making processes. As previously mentioned, there are as many ways to make test tiles as there are to make the work itself, and the process you use will likely be similar to your main making process. The most common options for test tile production are hand building, throwing, slipcasting, extruding, press moulding, slab building, and using failed pieces. There are numerous options within each process, and I'll only have used or even considered a small number of them, so please feel free to add more thoughts in the comments. But here's a little extra info for each type. Hand building. This might be my favourite way to make test tiles. At the most basic level, you're just taking a small amount of plastic clay and squidging it into whatever design you want. A simple method is to roll the clay into a rough cylinder and squash one end into the table to give it a wider base. This takes seconds and can be done with a tiny amount of clay, making it ideal for quick tests of small batches of clay. It gives a good vertical surface for the glaze to flow down, takes up relatively little space in the kiln, and should give a good application thickness. The downsides are that it can be harder to add things like appropriate texture and edges to the test. They can be unstable, although there are ways to fix that, and there isn't much space to add information to the tile. One easy improvement is to get a small slab of plaster. You can add a texture or design if you want to, which I have done here by adding a few small indentations which give the test tiles raised dots like my impulse pieces. You take your rolled out cylinder and you press it onto the plaster. This gives you a flat surface with whatever design you added to the plaster. It doesn't really slow the making process down at all, other than the one-time cost of making the plaster slab, and it gives you more information for every single test tile. Throwing. Typically this is done by opening a ball of clay down to the bat, widening out into a donut, and then pulling up a wall from that. This gives you an inverted T cross section, which can then be cut to the desired width for test tiles. There are several advantages to making test tiles this way. It's relatively quick to throw this shape and it provides dozens of tiles at once. It's easy to match the wall thickness, surface quality and rim quality of that of your other thrown pieces. Just make it the same way you normally would make a piece. It's easy to brush coloured slip or underglaze onto one side of the test tile if you want to test two colours in a single tile, and the flat base gives it a good surface to write on. If you're looking to throw some test tiles for the first time and aren't sure how much clay to use or how wide to open the ball of clay before pulling the wall up, I did a relatively simple calculation. It makes some basic assumptions of the cross-sectional area and density of the clay, so you might need to adjust the number slightly to suit your situation, but I found that if you divide the weight in grams of the clay by 50, you get the width in centimetres. So a 1,000 gram ball of clay would be thrown to about 20 centimetres and would give a good test tile size. Slipcasting. This will be the obvious choice for potters who slipcast their main pieces. Test tile moulds can be a simple one-piece mould or a more intricate multi-part mould, depending on what's suitable for the maker. There are very few design limitations when it comes to slipcasting, but the complexity of the whole process means it's not one I'd recommend to anyone who isn't already familiar with slipcasting. In my opinion, this way of making test tiles produces the best result out of all of them, but it is a lot more work to get started in than any of the others. Press moulding. In some respects, this is a similar approach to slipcasting, but with plastic clay rather than slip. You press clay into a mould and then remove the clay. There are more limitations than with slipcasting. Hollow forms will be trickier and it's harder to get a perfect impression, wall thickness will vary more, etc. But there are advantages too. Firstly, it works with plastic clay, which is quite important if that's the type of clay you use. Secondly, you can remove the test tile immediately after pressing them in. Slipcasting can require hours between casts, which allows for a much faster production from a single mould. This is now my go-to process after I made a robot-themed press mould using a 3D printed robot and just pressing clay around the outside and bisque firing it to make a bisque mould, which is even faster and easier than working with plaster, although the quality isn't quite as good. But it allows me to very, very quickly produce lots of these little robot test tiles, which are my new favourite way of testing glazes. I'll add a link to the 3D printable robot that I designed and the video where I show how I made them in the description. Extruding. There are several different ways of extruding clay, and the scale and design of test tiles will be affected by the extruder options available to you. Smaller handheld extruders, like the one I use for my handles, can extrude a strip of clay that can be formed into a vertical test tile in a similar way to the hand-built test tiles. Larger extruders and pug mill with an extruder die attachment can extrude larger complex forms. The die will generally have a design of the cross-section of the test tiles, which is either an inverted T or an inverted 7 shape, and a long length of this will be extruded and cut up. This can be an incredibly efficient way to mass produce test tiles. They can also be a great way to make flat test tiles quickly, and if you have a large extruder with a hollow die, you can actually make hollow, hexagonal or round tubes and use those to test. Slab built. Another way of making flat test tiles is by cutting them out of a slab. When firing a test tile horizontally, flat on a kiln shelf, you won't learn much about how a glaze will behave on a vertical surface. This can still be an appropriate way to test glazes if you make predominantly flat pieces, and can also be useful when you know a glaze's behaviour on vertical surfaces and just want to quickly test a wide range of colorant options or blends. You can also make a form that holds flat tiles at an angle during the glaze firing, allowing you to see how much glazes will flow, but without the need for the tiles to be self-supporting. You can also form slab cutouts into little bowls, which can be made quickly and are a great way to test some aspects of glaze behaviour. Failed pieces. One of the best uses for failed pieces, especially if they developed an issue during the bisque firing and can no longer be recycled back into usable clay, is to test glazes on them. The piece will likely have all the characteristics of your finished pieces, as that's what it was intended to be, and therefore makes a perfect test tile. The downside to these is that they're not efficient or reliable way to make test tiles in significant numbers, and they'll take up more room in the kiln than a typical test tile. Actual pieces. I wouldn't recommend these as your only test tiles, but using smaller, full quality pieces can be a great way of testing glazes. I use small tumblers and bowls as my final round of tests before scaling up to a full-size piece. They use more material and take up more space in the kiln than other test tiles, but they're functional pieces that can have a second life beyond the glaze test itself. With my small bowls and small tumblers, I use them as free gifts to send out with my larger mugs and bowls. The advantage to that is that they nest inside them for easy shipping, and it allows me to learn what I want from a test tile that can then go on to be used by someone else afterwards. Tips. Given how varied the specifics of test tiles can be, some of these likely won't apply to your situation, but these are things that I've found useful over the years. Don't limit yourself to one size and style of test tile. Initial glaze tests can be done on the most basic and quickly made test tiles, and you can move to more complex test tiles as you narrow down your testing to just the most promising glazes. This will save you a ton of time, but also allow you to have more complicated and more useful test tiles. Get as much information as possible from a single test. If you can, have multiple surface qualities on a single test tile. I usually coat the back of my test tiles in black slip to see how the glaze will behave over light and dark clay in a single test tile. I also try and have a flat surface and a textured surface on the same test tile. Use glaze efficiently. I like to mix up the smallest amount of glaze to test that I can. Often this will be a 100-gram batch of base glaze that I might split into 4 colorant tests, so only 25 grams of base mix in each. In order to dip my test tiles in such a small amount of glaze, I've found containers that are just the right size and shape. The same logic applies to the small tumblers and even to larger tumblers, where having the right size container and making the most of displacement allows me to dip a piece in a relatively small amount of glaze. Designing your test tiles with that in mind will pay off. Think about the end use when picking a test tile design. Will they be displayed on a wall or stuck to a bucket of glaze? Or do you just not have very much space in the studio and have boxes of T-shaped glazed test tiles that are taking up loads of space? In any of those cases, you might be better off making flat tiles or adding a notch to your freestanding tiles so that you can snap the foot off after they've been fired. It's possible for the tiles to have value after they've been used for glaze testing. This is a trade-off though, as making nicer test tiles invariably takes more time and effort, but it's less wasteful in a material and energy sense. In conclusion, there are lots of options and no universal right answers. Considering the various factors before picking a test tile process and design will allow you to get the maximum value from them with the least amount of effort. If in doubt, try all the options that make sense to you and see which ones you prefer. I have some experience with most of the processes I've discussed here, but there are some that I haven't tried myself, and I'm sure there's some that I haven't even thought of when I was writing this. So please leave anything in the comments that you think might be useful for anyone else, and let me know what you think I missed.